Okay, kids, just a little refresher about inverse trig. Remember that none of the 6 trig functions have an inverse on the entire domain because they don't pass the horizontal line test. But remember that we can restrict them. So arcsine is only allowed to be between negative pi halves and pi halves, because if you drew a line from here to here, then it passes both the vertical and the horizontal line test. Arccosine is only defined between 0 and pi, and arctangent is only defined between negative pi halves and pi halves. This doesn't come up a lot in AP Calculus, but just a reminder of what it's saying, right? Remember that inverse cosine, again, the domain and the range have switched places. So when it says arc cosine of 1/2, that's like saying the cosine of some angle equals 1/2, right? This is the y value in the original function. And so you have to know that the restriction is 0 to pi, and you have to tell me where between 0 and pi does cosine equal 1/2. So cosine is x, so I think that the answer there is pi thirds. So in a normal trig function, x is the angle and y is the value, but in inverse trig, x is the value and the y answer is the angle, right? So just a couple more. Arc sine of 0, where does sine equal 0? Well, if you're only restricted between negative pi halves and pi halves, then the only place where sine is 0 is right here at 0. So the answer there is 0. And remember that also you can do this on your calculator. So you want to be in radian mode. Remember, you should always be in radian mode. And that's the arc cosine on your calculator is the cosine -1, but you usually have to hit second to get that. And then you just type that in, 2.498 would be the answer to that. Okay? But what we're going to do here is we're going to talk about the derivative. What would the derivative of arcsine be? So I'm going to show you kind of a proof of this, and then I'm just going to give you the values of the other ones. We could do a proof of all 6 of them if you want, but I don't think you really care to see that, right? You probably don't care to see this one, but I'm going to show you anyway. So first of all, remember that y equals arcsine of x means that if you switch the x and the y, that's the same as saying x equals sine of y. So we could come over here, y would be your angle. So if I made y my angle right here, sine of y is x over 1. So sine is opposite over hypotenuse. So we could label this triangle, if this is y, opposite over hypotenuse. And we could even solve for this side of the triangle, right? And if I solve for that side of the triangle, that would be like saying x squared plus b squared equals 1. And so then I would get 1 minus x squared, and I would take the square root of both sides, and I would get the square root of 1 minus x squared. And those would be my 3 sides of the triangle. We're going to come back to that later. All right, what if I wanted you to take the derivative of this? Well, I don't know how to take the derivative of arcsine, but I can take the derivative of this because it means the same thing. So the derivative of x is just 1. The derivative of sine is cosine, but here's the tricky part of this, and we'll talk about this more later on. But normally we take the derivative with respect to x. So when you take the derivative of y, this is still cosine of y, but we have to say times the derivative with respect to x. So times dy over dx, okay, which just means our derivative. And then if I solve this for here, I would get 1 over cosine of y equals dy over dx. And really, if you wanted to be fancy here, cosine of y is really just secant of y, right? And then look up here at my picture. With y, could you tell me the secant of that? Well, secant is adjacent over hypotenuse, so that would be square root of 1 minus x squared equals dy over dx. And that is the derivative. No. I did it backwards. Oh my gosh. Okay, sorry. It would be 1 over the square root of 1 minus x squared. Because secant is hypotenuse, which is 1 over adjacent. Sorry, I was doing cosine. So the derivative of arcsine is this. And we could do this for all of these, but I'm not going to do it all. I'm just going to give them all to you. Okay? So the derivative of arcsine of x is 1 over the square root of 1 minus x squared. And what's fantastic is that the derivative of arc cosine is the exact same thing except for negative. Negative 1 over the square root of 1 minus x squared. The derivative of arctangent, which was on that circuit, is 1 over 1 plus x squared, no square root. And the derivative of arc cotangent is just the negative. Negative 1 over 1 plus x squared. So see how they kind of go together? Now this is where it gets crazy. The derivative of arc secant is 1 over the absolute value of x times the square root of x squared minus 1. Oh, I don't have enough room. So it's switched from the other one. And the derivative of arc cosecant is negative 1 over the absolute value of the square root of x squared minus 1. So although there's 6 of them, there's really just 3. And then all the c functions are still negative. So remember that cosine and cosecant and cotangent all have negative derivatives? Well, also arc cosine, arc cotangent, and arc cosecant are negative. But obviously they're not going to always just be an x in the bottom. So we have to talk about like the chain rule or the u substitution. So that's what's on the next page here. If u is a differentiable function of x, you have to also multiply by u prime, kind of like with the ln, where it's u prime over u. If u is just x, then it's just a 1 on the top, right? But if u is something else, then that's where you have to do the u prime. And so that's what these are. You're going to have a quiz over these 6 with the u, also these 6 with just the x, so that's 12, and just the regular 6 derivatives, 8, so that's 18 that you're going to have next week. So practice. All right, I want to do a few of these before I run out of time already. So find the derivative of these. And so I'm going to do this with kind of the u just to help you. Haha, I said u twice. So the u is always what's here. So in this case, u would be t squared. So u prime would be 2t. Okay? So then if you know your formula, and this is where you're going to look back today, but the formula for arc sine is u prime over the square root of 1 minus u squared. So u prime over the square root of 1 minus u squared. U prime is just 2t, and this would be the square root of 1 minus t squared squared would be t to the 4th. And we're not going to do anything with that. Okay? Look at this one. The derivative of arc cotangent of 6x. Again, this is my u. So if u is 6x, then my u prime is just 6. So if you look back at arc cotangent, cotangent's negative u prime over 1 plus u squared. Let's go back just to make sure that I'm correct. Negative u prime over 1 plus u squared. My advice is to try to write them out and then go back and check. Kind of a good way to check them. So negative u prime would be negative 6 over 1 plus 36x squared. That's it. It's not much you can do with them. Let's do a couple more. What about this one? X times arctangent of 2x. That is 2 functions multiplied together, which means I have to do the product rule here. Yes? So the product rule would be, this is my first function, this is my second function. So the derivative of x is just 1, so that's times arctangent of 2x, plus, leave the x alone, and the derivative of arctangent is u prime over 1 plus u squared. So u prime is going to be 2 over 1 plus 4x squared. And there's not really a whole lot you can do there, kids. I'm just going to write this as 2x here. I'm not going to get a common denominator. That's going to be my answer. But product rule, quotient rule, chain rule, it can all show up here, okay? So what about these two? And then I think I skipped, oh no, there's another one. Arctan sine of x over 2. So think about this one. U is x over 2, or that's the same as 1/2 x. Some people struggle with that. So that's just, so u prime is just 1/2, right? You don't need the quotient rule there. You just separate the x from the 1/2. So this is what? U prime over the square root of 1 minus u squared. So this is where we have to remember our algebra of u prime is just 1/2 over the square root of 1 minus u squared. So that's 1 minus x squared over 4. But here's where you're never going to leave your answer like this, okay? Like you have to simplify this. And we can't do a whole lot until we get a common denominator under here. So if I got a common denominator with 1, that would just be 4 minus x squared all over 4. Because 1 over 1 is just 4 over 4. And why is that a good thing to do? Because now I could write this as the square root of 4 minus x squared over the square root of 4, which is just 2. And if you think about simplifying it, maybe you just know it crosses out, or if you really want to rewrite it, you could say that's times 2 over the square root of 4 minus x squared. So I want you to be able to simplify it down to this. Okay? We'll end right here on this one. Arcsecant of 2x squared. Secant and cosecant, I'm not going to lie, I've never seen those on the AP exam. I could be wrong though, but with the absolute value, so it is u prime over the absolute value of u times the square root of u squared minus 1. So u is 2x squared. So du is 4x. Sorry. U prime is 4x. So my derivative here is going to be 4x over the absolute value of 2x squared times the square root of 4x to the 4th minus 1. And then here's where, especially with multiple choice, you got to be really careful about simplifying. But since 2x squared, since you're squaring this, do I really need these absolute value bars? I don't, right? Because this is always going to be positive. So you could erase these absolute value bars on this one. They're not needed. And then we could simplify it a little bit, right? We could say that that's 2 over 2x times the square root of 4x to the 4th minus 1. Oh wait, why didn't I just, this 2 wouldn't be here anymore, right? It would just be 2 over x. And this could be negative, and so we're not going to put the absolute value bars back around that because this could be negative on top, not negative on the bottom. So this would be my simplified answer. Okay, so I have some more here if you want to start trying them. We're going to do a few more in class tomorrow, and then I'm going to give you some to practice, okay?